Hey, it's Mr. Allred, and we're going to work with rational expressions here. And the thing to remember is expressions. The things we can do with expressions are combine them, simplify them, rewrite them. It's not an equation where we solve for a variable. It's an expression where we can rewrite things. So rational expressions are fractional expressions with a variable in the denominator. So basically they are fractions, but we're mainly going to work with fractions that have polynomials in the numerator and denominator. So maybe a quadratic or maybe a cube or even a linear function in the numerator or denominator. And when we say simplify rational expressions, this could be carrying out operations such as add, subtract, multiply, divide fractions. It could also mean factoring and reducing, which is basically what we think of when we think of simplifying a fraction. So that's what we're doing. So let's see some examples and where we're going. So this expression is 6x squared minus 19x plus 3 in the numerator, 4x squared minus 36 in the denominator. So this is already one fraction. So we don't have to worry about combining things, but we probably should try to break it down and see if we can reduce. So I'm going to take both of these. I'm going to start with the numerator, which is 6x squared minus 19x plus 3. So our factoring techniques are going to be pretty useful because since it's already one fraction, the only thing we could do is possibly find a common factor and cancel out. So let's try and factor both the numerator and denominator and see if that happens. So nothing will come out to start with, so we need two things that multiply together to give us a times c, which is 18, but add up to be b, which is negative 19. So looking at this, let's make something look a little bit neater here. But looking at this, we need two things that multiply together to give us a positive, so they're the same sign. They add up to be a negative, so they're both negative. Negative 1 and negative 18 are the numbers. And the factoring process continues by using the 6x as the leading term in each factor. So 6x minus 1, 6x minus 18. I can't pull anything out of the 6x minus 1, so we will just have it. But the 6x minus 18, I can pull a 6 out, which leaves x minus 3. And remember, if I pull something out here, I throw it away. So that numerator, 6x squared minus 19x plus 3, factors into 6x minus 1 times x minus 3. Okay. Now let's factor the denominator and see what happens. So that denominator is 4x squared minus 36. And this is actually a difference of squares if we treat it as 4x squared being 2x, that quantity squared, and 36 being 6 squared. So in this case, we can think of the a squared minus the b squared, and that factored into a plus b times a minus b, which would be 2x plus 6 times 2x minus 6. So let's see what happens there. So if I write that out, 2x plus 6 times 2x minus 6, it's not so obvious that something cancels, but I could go ahead with the bottom and realize, if I'm comparing them, that 2x minus 6, 2x plus 6, I could pull a 2 out of each one of those. And if I do that, and I could have done that to start with, but let's see here. Up top I still have 6x minus 1 times x minus 3. But if I pull a 2 out of both pieces of the denominator, I'll have 2 times x plus 3 times x minus 3. And there I can see that I can cancel out an x minus 3 in the numerator and denominator. And that will leave me with the simplest version I can get, which is 6x minus 1 over 2 times the quantity of x plus 3. Now you could push that 2 back into the bottom, but usually I like to leave things factored as much as possible when it's realistic, just to show that nothing else would cancel. So we started with one fraction, so that's not an issue, but we did cancel out a common factor. Okay, you may agree or disagree that this simplified version looks better, but there's not unnecessary terms there. So the next problem I'm going to do is simplifying this expression, which is the numerator 2x squared plus 5x minus 3, and the denominator is 6x squared plus 18x. So we're just going to revisit our factoring techniques, and we're going to break down 2x squared plus 5x minus 3. Nothing comes out in the beginning, but we need two things that multiply together to give us a times c, which is negative 6, and add up to bb, which is 5. So they multiply to give us a negative, so they're different signs, and they add up to be a positive. So the bigger number is positive. It's pretty easy to see here that we want negative 1 and positive 6. And when we write out our factors, we'll lead with that 2x minus 1, and 2x plus 6. Nothing comes out of the 2x minus 1, but I can pull a 2 out of the 2x plus 6, which will leave me 2 times x plus 3. And remember that 2 we get to throw away. So my numerator factors into 2x minus 1 times x plus 3, and you could always fold that back together and verify that. The bottom term here, the denominator, 6x squared plus 18x, it's not a trinomial, so if it factors there has a common term, and I can pull a 6x out, which will leave an x plus 3. So 6x times x plus 3 in the denominator. And very quickly I'm able to realize I can mark out an x plus 3 here. And when I carry this over, the simplified version is 2x minus 1 over 6x, and there's nothing else you can do with that and keep it as one fraction. So we found a common factor in the numerator and denominator, and we're able to reduce it. Okay, so we're simplifying fractions is all we're doing. This next problem is actually a multiplication problem. So you may remember that, or you may not remember, but whether you do or not, you may remember that if you multiply two fractions, such as a over b times c over d, you multiply straight across, so ac over bd. So we could do that here, but the terms we got would just make a really large, crazy fraction. So let's kind of work towards simplifying. So the problem we actually have, the first fraction is x squared minus 3x minus 4, and that's over 2x squared minus x minus 3. And that's times the second fraction, 2x squared plus x minus 6, all over x squared minus 2x minus 8. So we need to factor every single one of these things. So let's see. I can look at a couple of these and do them very well. So the first fraction, x squared minus 3x minus 4, you can do this on your own paper, but it should be x minus 4 times x plus 1. You can work out the factoring techniques there. The denominator, 2x squared minus x minus 3, I'll walk through that. So I need two things multiplied together to give me negative 6. Add up to be negative 1. That's an interesting concept here. Oh, I'm sorry. My brain's not working. So this could be negative 3 and positive 2. So I'll lead with the 2x minus 3, 2x plus 2, and I can pull a 2 out of the second term to leave x plus 1 when I throw that 2 away. So that denominator factored into 2x minus 3 times x plus 1. So I've got my first fraction factored, and I can already tell that I can throw out an x plus 1 in the top and bottom. Alright, so now I need to break down the second fraction, which the numerator is 2x squared plus x minus 6. So if it doesn't start with 1, I usually have to do this and work it out myself, but a times c is negative 12, and b is 1, so I believe that is 4 and negative 3. So again, lead with the 2x plus 4, 2x minus 3. I got messy when I tried to clean up. It's weird how that happens. You try to make something look better and it ends up worse. So let's see here. I can pull a 2 out of the first one. I'll throw it away, but it'll leave me with x plus 2 when I do. And 2x minus 3 carries. So that numerator factors into x plus 2 times 2x minus 3. Okay. And then I've got one more, which is the denominator. And if I look at it, x squared minus 2x minus 8, I can tell that that factors into x minus 4 times x plus 2, it looks like. And you can multiply that back to check it. But coming back through here, I now see that I have an x minus 4 in the top and bottom. I have an x plus 2 in the top and bottom, and 2x minus 3 in top and bottom. So everything reduced, surprisingly. Now that doesn't mean we get 0. It means everything reduced. So if you had something like 5 over 5, you'd reduce it down to 1. So if the numerator and denominator actually turn out to be the same, or everything cancels out, the result is 1. So this big complicated product of fractions over here was just an unnecessary complicated way of writing 1. Alright. Take note again of multiplying fractions together if it's been a while. Alright, we'll do some more examples here in the next video.